Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about calculating ship motions in irregular sea states using the Generic Frigate project as a demonstration. Um, Response amplitude operators are nice, but they're just a calculation in a regular seaway, and it's not quite the same as looking at a ship response in an irregular sea state, which is much more representative of what you might find in a specific loading scenario. So we're going to do that through SeakeepRandom. So we'll go add existing data. We'll go SeakeepRandom. We've got a file already set up for this, and let's make sure at the beginning here for ship motion database file name we're selecting the file that was generated for this specific project. There's going to be a range of speeds to investigate, as well as the sea directions. So the difference between this and the regular Seakeep regular and calculating the RAO is that we're looking at a much more representative sea state, which you can pick between a few different options, including a custom spectrum. So this is a fairly sizable sea state, not the biggest one ever, but there's a significant wave height of just over 3 meters and close to the 10-second peak period. And as before, we can add sea keeping positions. There doesn't seem to be one added by default in the project files, but you can pick one and locate it wherever you want in the location of the ship coordinates, as well as provide some options for motion-induced interruptions and motion sickness index. So we'll go OK for that. Again, this is a very fast calculation, so we'll just go save and run. And if you look at plot motion RMS, it's going to give a representative idea of the ship motion in as a function of the relative sea direction from the ship. So we're picking a ship speed of 0, and you get an idea of how much ship motion there'll be in the different degrees of freedom: surge, sway, heave, roll, and so on. And of course, we're seeing the biggest roll response kind of around the 90 degree mark. But there's going to be some variation just because of the spreading function of the irregular sea state, and then some differences happening depending on the forward speed of the vessel as well. Now, if we look at the output, you'll get lots of information on the RMS motions, accelerations, zero-up crossing periods, and depending on the sea-keeping position the location of the sea-keeping positions that you add, you'll get, and the options, you can see some ideas of motion-induced interruptions and seasickness index as well, depending on the scenario that you're looking at. It's a pretty fast calculation, so it's good to play with inputs on this and see the variations. Thanks for watching.